Hi, this is Mr. Max with Sankofa Mathematics. So I have here two questions that I would like you to try out. It's in on integration, and the question here, the first one says you must find the integral of 6 times the quantity 5x minus 1 all squared minus 1 all upon the cube root of 5x minus 1 with respect to x. And then the second one, so I'm going to scroll down so that you can also write it down. Okay, you're supposed to integrate the quantity 4 multiplied by 2t plus 3 cubed minus 2t plus 3 squared upon the square root of 2t plus 3 with respect to t. Okay, so I believe you can pause the video and then you can try the questions and see if you're getting to the answers. So this here is the rule, and I hope by now that you don't have to prove the rule, but at least that you have knowledge on how to apply it. Okay, so let me start right from the beginning. So the first thing that I can do is I can take out the 6 and I put it on the outsides, like take out that 6. So I have here 5x minus 1 all squared, and then I'm gonna write this one on this side. So what I also do is this 5x minus 1, it's going to be raised to the power of a third. And then, so I'm putting everything over that same denominator, 5x minus 1, all raised to the power of a third with respect to x. Okay, so basically you have to deal with the algebra in here. So before you start integrating, so 6. So once you are here, since you are dividing, you are going to subtract the quantities. So basically you're subtracting 2 minus a third, and that's give you 6 minus 1. So that's going to give you 5 over 3. Okay, so now I have 5x minus 1 raised to the power of 5 upon 3 minus, all right, so here again, this one becomes simple. It's just going to be 5x raised minus 1. Now it's going to be raised to the power of negative a third dx. So I hope that you do realize that if you are now inverting this fraction, you're going to have a negative index there. Right, so now we are actually ready to apply our rule. Okay, so I'll just take this off so that it's not so messy, right? But do apply some side work as you go along. Right, so now we have going to say it's going to be 6 multiplied by, okay, so now here's the thing, we are going to add 1 here. So if we add 1 here, that's giving us same as 3 over 3, so that's going to be 5x minus 1 raised to the power of 8 over 3. And then you're going to multiply that 8 over 3 with the 5. So you're going to say 8 over 3 times 5, well, that gives you 40 upon 3. So that is what we are going to have under here, 40 over 3. Okay? So we are applying that rule. We add 1 and multiply that by the value of a. And here again, we are going to add 1. So if you add 1 to a third, it's the same as adding 3 over 3. So that becomes 5x minus 1 raised to the power of 2/3 now. Okay? And this is going to be all over that 2/3 that you have got as an answer. Now you must multiply it with the value of 5. So that gives you the value of 10 over 3 plus the constant of integration. So I'm just going to take away my side work and go back to the law so that at least you are very well aware of how you should do that. Okay. Right, and don't forget, since you're integrating, you have to always write plus c. Now, we are not really entirely done, but we have integrated as far as we can. So we're just going to play around with the algebra. So this becomes then the same as 6 times 3 upon 40. And so we'll switch that one there. And then you have got 5x minus 1 raised to that power minus 3 over 10, and this is 5x minus 1 raised to the power of 2 over 3 plus c. Alright, so we're just going to simplify this a little bit. So basically, if I'm coming here, I know that there's a number that goes here, 2 goes here, obviously 3 times, and 2 goes here 20 times, so I can actually clean this up. And this is going to be given as 3 times 3, which is 9, and this here can be written as a cube root of the quantity 5x minus 1 raised to the power of 8, and this is going to be over 20, minus, well, this is going to be 3, again, multiplied by the cube root of the quantity 5x minus 1, put that in bracket, all squared, all over 10, plus c, which is the constant of integration. Okay, so that is what that question then simplifies to. So if you agree with me, there's quite a lot of algebra work that you need to pay attention to, and then you should be on the right path. Okay, so I'm just going to scroll back up so that you can see I here haven't started integrating. So I first try to simplify the algebra here. As you can see, put everything over the same denominator, and anything, the cube root of anything is the same as that raised to the power of 1 over 3. And then I apply the law of indices. When you're dividing and the bases are the same, you subtract the indices. So 2 minus a third, okay, that gives us 5 over 3, and so on. Okay. Right, very important that you show your steps and then you eventually arrive at that answer. Alright, so we have a similar one here. You can pause the video, you can also try it. Okay, right, so what we have here is I'm going to take out the 4. So that wasn't a very good beginning. So I'm going to take out the 4. So I have got 2t plus 3. Okay, and it's raised to the power of 3. Well, let me just go ahead and put this over its own denominator of 2t plus 3, which should now be raised to a power of a half, because that's the same as square root, minus 2t plus 3 squared all over 2t plus 3 raised to the power of a half dt. Okay, right, so again, it will involve a little bit of work that you need to do in terms of when you are dividing, what do you do? So we're going to take these indices here. So I'm just going to have a little bit of side work so you can see. So I'm going to say 3 minus a half, so that's 6 minus 1. 2 times 3 is 6 minus 1, so that's 5 over 2. So once I do that here, this becomes 2t in brackets plus 3 raised to the power of 5 halves. That will be that 3 minus a half. Okay, so that 3 minus a half, well, that gives you 2.5. Then on this side, you're going to have, if you do your side work again, all right, so let me just clear that up so I can have enough space. So for my side work, can obviously grab a calculator. So you have got, and this one, very easy, 2 minus a half, well, that's 4 minus 1, so that's 3 halves. That is if you take this and you subtract it from that. Okay, so I get 3 halves. So this becomes then 2t plus 3 raised to the power of 3 halves, okay, dt. Okay, so let me just clean this up so that we have enough space. Alright, so now my algebra is sound. I can actually go ahead and now I can start to integrate. Okay, right, so once you integrate, so you're going to add 1, so it's going to be 4 times, so you add 1, so you have got 2t plus 3. So when you add 1 here, add 1 is going to be 7 halves, because it's the same as 5 over 2, plus 2 over 2. Okay, that gives you the 7 halves. So just to make sure that you follow how I get to that answer. And then obviously we're going to have minus, so here we have 2t plus 3. So if I add 1 here, okay, so I'm going to come back and do something else. I just want to finish adding my ones here. So because I started like that now, I was supposed to clean up this one, but I'm going to come back here because I'm going to have to multiply the 7 over 2 times the 2. All right, and that's what I'm going to divide with. So if I add 1 here, so if you take 3 over 2 and you add 1, that's the same as 5 over 2, so this becomes 5 over 2 plus c. But now I'm not done entirely, so what I'm going to do is I'm going to come back here. So let me just put this also in red, because I want you to be able to see what I have done there. So now I'm going to take that 7 over 2 and I'm going to multiply. So now if you multiply 7 over 2 times 2, guess what? You're just going to be left with 7. So all of this will be over 7. And the same applies here. If you multiply that 5 over 2 with this value of 2, guess what? You will be left with 5. Okay, so we're nearly there. So the only thing that now is needed is just for us to write it in nice ways with the square roots and stuff like that. Okay, right. So up to there, you should be 100% on the right path. So this becomes then 4 times, so this is the square root, power square root of the quantity 2t plus 3 should raise to the power 7 upon 7 minus the square root, because that's square root there, of the quantity 2t plus 3 raised to the power of 5 upon 5 plus the constant of integration. Okay, so I hope that, well, in order for you to do this type of questions, you definitely need to understand and to know your rules. Okay, so always refer back to your rules, and once you have your rules, then you should be able to know how do you integrate quantities of the form. Because remember, it is not, this is the beginning, right? So it's not that complicated. How do you integrate a quantity ax plus b raised to the power of n with that? So that gives you, obviously, you, if you integrate that, so I'm just going to write this answer under, which is the rule that I had there right in the beginning. All right, should, so all of this, if you integrate, it should be, well, 1 over a, and then inside here you're going to have n plus 1. All right, so maybe I should just write it a little bit neater, so I can have my 1 right in the middle. Then it's ax plus b and n plus 1, obviously plus the constant of integration, and also n cannot equal to -1, because if that is the case, then you will have here something that cannot be divided by 0. Okay, so once you know this rule, you will be fine. You should have no problem in solving questions of this nature. Okay, so have a look for that, and make sure that you understand and do enough exercises in order for you to be able to solve such type of questions. So I'm just going to scroll back so you can have an idea as to what I did here. So again, so I try to take out the 4, the constant, put it in front of integral. Okay, don't have to, but it's just ideally it works better, and that's why I do that. And write 2t plus 3 cubed over each denominator. So you have got 2 terms on the numerator. Write them over the denominator, each denominator. Obviously, it's going to be best if you change that root to power. And then you apply your indices laws when you're dividing by the same term or number or quantity. You subtract the indices, make sure that you do not make a mistake. And once you're here, now you can actually integrate, you know, differences in sums. And don't forget to put, when you do start integrating, that you must not forget to put your plus c every time when you do this question. Okay, so that is how this particular question is done. So I hope you can do much more and be ready for the upcoming examination.